This is for section 5.4 in the Green Book, and it's on scientific notation. All right, so scientific notation is used to describe really big numbers or really small numbers. For instance, distance from here to the moon is a very large number. Whether we're talking inches, miles, feet, kilometers, it's a very large number. It's something that we would use scientific notation, or something that is so small the human eye can't even see it, maybe an atom or a molecule. We would use a number in scientific notation to describe it. So, when we're doing scientific notation, it's always the same pattern. We take a number, it's multiplied by a power of 10 to a certain power. And that power has to be an integer, somewhere between 1 and 10. It has to be less than 10, but it can be 1 or greater. So again, we have any number. We need a number between, A has to be between 1 and 10. It has to be less than 10, but it could be equal to 1 or any number greater than 1, but less than 10. And our B here has to be an integer, a negative, positive number, or 0. So, for instance, the very large number, this is million, billion, trillion. Okay, so what we have to do is we have to create this number and turn it into a number that is somewhere between 1 and 10. So the decimal is naturally on the right side. We have to take that decimal and we are going to move it 1 space, 2 space, 3 space. How do I know when to stop? I have to stop when the decimal is in a place that takes me to a number between 1 and 10. So I've moved it 3 times, 4 times, 5 times, 6 times, 7 times, 8 times, 9 times, 10 times, 10 times, 11 times, 12 times, and I stop. So now my number becomes 3 7/78. I've moved it 3. Remember, we're not including a place for the comma, only the digits. So again, I'm going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So if I moved it over 12, and I'm really kind of making that number become smaller by 12, got 3 7/78, I'm going to multiply by 10, and the number of jumps that I did, since it's getting smaller, this becomes positive and gets bigger. When we're going from a decimal, however, I've got to move that decimal. This time I'm going from a small number and we're making it bigger. So I'm going to move it 1, 2, 7 jumps. I'm going to go 7 different times. Now remember, decimals are like fractions. And fractions, the way we show fractional amounts is with a negative exponent. So I'm moving it 7 decimals. We know that the new number, since I'm moving my decimal over 7 places to make that number become a number between 1 and 10. And so it will become 6 4/10. I always multiply by a power of 10. And since I went 7 jumps and I'm making it bigger, I have to show it smaller here. So this would be to the negative 7. If it starts out as a decimal, I've got to show it as a negative exponent, because negative exponents really are fractional or decimal amounts. Okay? So the number of times I move the decimal is what that exponent becomes. Whether it's negative or positive, if it's a decimal, it's going to be a negative exponent. If it's a whole number, it's going to be a positive exponent. All right? So, let's do it one more time. I'm going to do the first one. We're starting with our decimals naturally to the right. And now I'm going to move it 1, 2, 3, 4, 5, 6, 7. So my new number becomes 4 and 6/10, 4.6 times 10, and it's a whole number to begin with, so it's going to be a whole number there. I want you to pause the recording and try the next one. All right, now check your work. We start with our decimal to the left. We're going to jump 9, 10, 11 jumps. It becomes 6 2/10 times 10 to the 11th power. All right, I'm going to do an example of the smaller number. I'm moving my decimal 1, 2, 3, 4, 5 places. No, 1, 2, 3, 4 places. Remember, I have to make it become a number between 1 and 10. So I stop between the 5 and the 3. Since I moved it 4 places, it's started out as a decimal. I have to imply that with my power of 10. So it's going to be 5 38/100 times 10 to the negative 4th power. Pause the recording. You try the next one. Now check your work. Moving my decimal over 1, 2, 3, 4, 5, 6 times, I end up with 4 times 10 to the negative 6th power. All right. Now we're going to go, if you want, you can practice some of these, a few more, and pause the recording while you do that. Okay, now check your work. So it's 6 3/10 times 10 to the 4th. 7 245 thousandths times 10 to the 6th. 5 times 10 to the 10th power. Now I'm practicing my decimals. It's 8 7/10 times 10 to the negative 4th power. 6 53/100 times 10 to the negative 5th power. And 2 times 10 to the negative 7th power. So we started out, these numbers, the way they're written, the way we began, we call that standard notation. And we're writing now the information in scientific notation. From standard notation to scientific notation. Now we're going to do the opposite. We start with the number that's given, 3 6/10. Now, if it's a whole number, my answer is not going to be a decimal answer. So if it's a whole number, I have to move to the right. And I'm going to move my decimal 1, 2, 3, 4, 5 places. Okay? We're moving it 5 places. And then we end up with we're adding zeros in those empty spaces, and we end up with 360,000. Number 2, start with 843 thousandths, and this time, since I have a negative exponent, I have to turn it into a decimal number, we're going to keep it in the decimal form, so the only way to do that is to move it to the left. So I'm going to move it 7 digits. 1, 2, 3, 4, 5, 6, 7. I add my decimal, and then I always add a lead coefficient of a 0 decimal. Now, so one more time. We're given our information in standard notation, in scientific notation, and this time they want us to write it in standard notation or standard form. So I want you to pause the recording and you try the next few. Now check your work. you should have had 2,640,000,000. Number 4, you should have had 0.0000341, which was, okay, number 5 is 400 million, and number 7 is, there should be 1, 2, 3, 4, 5 zeros and the 7. All right, so now we've done scientific notation and going from scientific notation to standard notation and standard notation to scientific notation. We can skip the part with the calculator. All right. So you can use a calculator if you'd like for this. Basically, if we're given two numbers to multiply in standard form, we could convert them to scientific notation. So do 2 times 8, 2 times 10 to the, right, we could do this. 2 times 10 to the 3rd power times 8 times 10 to the 4th power. And then I could use a multiply 2 times 8, I get 16. And this would be 10. I use my rule of common bases, 10 to the 7th. But I'm not in scientific notation. If they want it in scientific notation, I have to make this number be between 1 and 10. So I have to make it get smaller, right? Because it's at 16. The decimal's naturally there. If I'm making it smaller by 1, right, and I put the decimal there, then I have to make the power of 10 get bigger by 1. If I make it smaller by 2, I have to make the power of 10 get bigger by 2. So I'm doing 1 6/10 times 10. Instead of the 7th power, I have to make it get bigger, since I made this right here get smaller by a tenth. Okay, and that's our final answer. Okay? If you want, pause the recording and try the next two. They're just using the scientific calculator. I can't do that right now. All right, multiplying in scientific notation. It's pretty similar to what we've been doing. I'm okay if you use a calculator with this. We're basically multiplying decimal with decimal, like base with like base. So we're just going to rewrite this using our commutative property. 2 1/10 times 1 1/5. 1 5/10. 2 1/10 times 1 5/10. And then we'll multiply the common bases together. 10 to the 8th power times 10 to the 6th power. When I multiply 2 1/10 times 1 5/10, I get 3 15/100. And then we're using our common bases, 10 to the 8th power plus the 6th power. That would be 3 15/100 times 10 to the 14th. Okay? All right, now you pause and try the next one. Okay, let's check our work. When I multiply I'm multiplying 5 63/100 times 3 4/10 and 10 to the 7th times 10 to the 8th. When I multiply it out, we get this. Now, are we in scientific notation? Notice they're asking us to have the answer. It's not in scientific notation because this is not between 1 and 10. So we have to make that smaller by 1 unit. Okay, I'm making it smaller by 1 unit. And if I'm moving it one place. So now if I made it smaller by 1 place, 9, 1, 4, 2, you have to write all those digits. If I made that smaller, this has to get bigger. Keep it in balance. 10 to the 16th. If I make it smaller by 2, I have to make it bigger by 2. Okay? And now I'm in scientific notation, making it smaller by 1, making it larger by 1. And that is our final answer in scientific notation. All right, I'm going to do the first one with you. I'm multiplying 8 times 1 and 2/10. We end up with 9 and 6/10 times 10 to the 25th. Okay. There's not really much work to do there, especially if you're using a calculator. Pause the recording and try the next few on your own. Okay, now check your work. 11 and 76/100 times 10 to the 16th is not in scientific notation, so I have to move it over, make it smaller by 1, and make this bigger by 1. So it would be 1 and 176 thousandths times 10 to the 17th. Okay, the next one, making it 2 and 405 thousandths times 10 to the 19th. I've got to make this get smaller, so negative 11 is going to get bigger. Now be careful here. It's getting smaller. To get bigger for that negative 11 power, we would go to negative 10. All right, dividing. We're doing the same thing. We divide our common bases, and we divide our decimal numbers. 9.1 divided by 9.5. 10 to the 12th, we're really subtracting, right? So I end up with, if I take 7 out here and 7 out here, I end up with 10 to the 5th. And then I do the division for the other part. So we end up with 2 and 6/10 times 10 to the 5th. Okay? Going to do the same thing. Divide the decimals together, divide the common powers together. We end up with 10 to the 12th power, but it's not in standard notation, so we have to make the decimal bigger. I mean, it's not in scientific notation, so it's 8 and 6/10 times 10 to the 11th power. If that gets bigger, that gets smaller. Got it? Okay. All right. Pause the recording and try the next two on your own. Now check your work. All right, we have one more thing to learn in scientific notation, and that is how to add and subtract. Okay, when we're adding and subtracting, first thing we need to do is get the powers to the same unit. So notice I have it's 10 to the 4th power and 10 to the 5th power. So the first thing I'm going to do is try and make this one smaller, right? So we're both in scientific notation. If I make, let me go back and just show you. If I make to make this smaller, 10 to the 4th, then this would get bigger. So it becomes 92 and 4/10. Okay? 6 and 89/100 times 10 to the 4th. Okay. So now that I'm in, oops, I should have put the parentheses. Now that they're both at the same, they're both being multiplied by the same common base, what we can do is we add the two decimals, 6.89 plus 92 and 4/10, and then we multiply them both by 10 to the 4th power. So we're going to add those up, right? 6 and 89/100, 92 And then we end up with 99 and 2900ths times 10 to the fourth. Now, I'm not in scientific notation. If they want it in scientific notation, remember, I've got to make this number become a number between 1 and 10. So I'm going to move the decimal to the left. I'm making it smaller. So this is going to have to get bigger. So it's 9 and 929 thousandths times 10 to the fifth power. Since it gets smaller here, it has to get bigger here. Got it? Okay. And that's adding in scientific notation. All right. Evaluating. Let's see. So why don't you try the next one on your own? Now check your work. Should have had 1 and 6385 times 10 to the ninth power. All right, so evaluating the expression. Express the result in scientific notation. Since the second piece is not in scientific notation, you've now got to move your decimal over once, twice, 3 times, 4 times, 5 times, 6 times, 7 times. So it's 1.161 times 10 to the sixth power. Okay, so the first thing we have to do is convert that to scientific notation. Now we have to get them to the same level. So they're being multiplied by the same common base. And so now that I'm in scientific notation, oops, it was to the seventh power, 3, 6, 7, yeah. I would go to the point where you're making them both go to the lower number. And when you go to the lower number, I guess it doesn't really matter. You can move them both to the eighth power, move them both to the seventh power. Eventually, you're going to have to make them go into scientific notation. So then remember, we're subtracting this time 78 and 3/10 minus 1 and 161 thousandths. And the whole thing is going to be multiplied by 10 to the seventh. And so then we get 77 and 139 thousandths times 10 to the eighth. I guess if you had gone up to the eighth power, then you probably wouldn't have to rewrite it in the end. So if you go to the bigger power, I don't think you have to rewrite it in the end, change it back to scientific notation. So to make this get bigger, remember, I'm moving it over once. Okay, moving my decimal, so it becomes 7 point, and you have to write all these digits, 7139, and if that got smaller, then this gets bigger. Okay? All right, now you guys pause the recording and try the next one on your own. All right, now check your answer. Let's try it again. This time, you're going to have to, we've talked about this. We have to convert it to scientific notation first, and then go. All right. Now check your work. So tell them to get quiet out there. Remember, I have to first convert it to scientific notation. Then we are going to convert it to both to the, when you're adding, it doesn't, I guess, if you go to the bigger one, it would be better to go to the bigger one, and then you can, and there we go. Let's practice it again. Convert your 645000000, convert it to scientific notation, and then your answer should be 6.3673 times 10 to the ninth. And that's the lesson. This should be the hardest lesson all week. Remember, I will not quiz you on this right when you come back. I will answer any questions you need. We'll go over the material.